Hi, I'm Neela and I'm an aspiring data analyst currently doing projects to gain sufficient technical knowledge in Google Colab, taking data sets from Kaggle. In this Vibe Code capstone project, I'm taking Agents for Good, which is titled the Automated Smart Irrigation and Soil Health Pipeline. Water scarcity in United States is critically growing crisis and not even here, all over the world, with over 56% of the states are experiencing various levels of drought conditions. This project prevents overwatering and also maintaining soil health. This is done with the help of Gemini and anti-gravity too. The first question to Gemini was, so it is with the help of Gemini where I started off. And the first question was, generally the sprinkler system is connected to sensors. So how, how can we start the project with that? So a prompt is given to anti-gravity saying to create a smart irrigation pipeline with all the requirements. As you can see here, it's been done twice because I don't see the smart irrigation pipeline, but instead it got saved in Google Cloud Serverless app as part of 5-day assignment. And it had come up with a setup with data requirements.txt and src, which is basically the source file. I've done it twice, so I'm just scrolling down. This has all the sensor reading. The schema has the sensor reading, irrigation zone, and the irrigation uh, uh, schedule. As you can see, if I click on review, it would tell me what does these include. And this is where you have the model context protocol, MCP, that standardizes how AI interacts with the soil sensors. The very first question to Gemini is, lot of times the heavy rain is predicted or chances of shower is 85%, but the irrigation system skips the watering on that day. But as forecasted, it never rains. Now, the irrigation system, how it works. If this is a case for a week during summertime, so Gemini gave a Python code and prompt to anti-gravity is given, which changed the general if-else loop to pedantic model where it acts as a data gatekeeper to confirm incoming data strictly adheres to business logic constraints to ensure data integrity at runtime. A UV-con is generated to run this application for real-time communication. Yes, you can see that in the top. And I'm sorry, I just went slightly down. Sorry about that. But I'm just showing the laptop keys. The second question to Gemini was if there is no or less percentage of chances forecasted, but a heavy rain is predicted, but it rains heavily unexpectedly. Now, how will the irrigation system react to that? So using the Python code, a prompt is sent to anti-gravity again, which checks the soil moisture levels and decides the action. SRC is updated to include critical hardware safety gate check for overwatering. The third question is, if during peak summer the soil moisture is critically low and how to approach this. That's where the curl comes in place for agents to access the web and look for real-time data and to override the normal or base watering levels, instead adjust the watering levels. Then the last question to Gemini is does heavy rain or no less rain alters the pH of the soil? The answer from Gemini was The answer from Gemini is yes, and it's called leaching. So soil pH levels is also taken into consideration, and Python code was posted to include and check pH levels. Now SRC or source code is modified with all factors: water, sensor data, rain, and soil health with mock data. And now we have encountered um, a pedantic error because there was an empty string, and this is again fixed with another set of Python code by Gemini. And all the testing is done to verify every set of condition posted. Now, while I'm scrolling down the anti-gravity for final set of code, I'm also going to talk about the deployability and real farm viability. The architecture has more Python services. It can easily deploy directly to real farm edge gateway like industrial IoT hub located on a real farm. Because the source code, which is MCP server.py and agent.py, are separated, the entire system can be wrapped into a Docker container, allowing for zero downtime updates even over low bandwidth cellular farm networks, which is basically cost effective. The schema.py API server can transition to process the signals from real soil probes and behaves exactly with shifting environmental variables. Looking forward to hearing from you.